what I am going to do is open a different method. Actually, I'm going to grab the TCD method because it should have all of the component names in it. So if I go to components, I did this yesterday, I've got all the component names.
You already put the time? Retention time?
Yeah, the retention time is in there.
Okay.
We will just update it when we run these.
Yep.
But I'm going to save this. Output will be both detectors. This will be just single output, right? And this will be Arnold processing method. And all I did there is so I still have all the components. Okay, so what we need to do is build out, because we're going to be calibrating by curve, so we need to build out our calibration table for each component. So we'll go into our calibration tab. So backstep actually, I'm getting there by going into our components tab and then going to edit components. So this is our components window. So information for integrating those components, essentially the retention time window, and the component's name. So at 443 minutes, if you have a peak, it's going to be labeled hydrogen. Yes. And for hydrogen, we're going to want to build a calibration table with a few options here. So we will do calibration by using a curve. We're going to make our curve first order. We're not going to do any treatment of the origin. We'll let it find its own origin level. And then levels. And so we have 1, 2, 3 levels. Okay, so level 1, I'll just write level 1, level 3, whoops, maybe I'll start with level 2. And then level 3. So our amount for level 1 is 1000 ppm, so 0.1%. And then we have 1% and 5%. Okay. And we need to go through the process for carbon dioxide. Use curve, first order, level 1, level 2, level 3, 0, 1, 5. So we're just building up this calibration, and then what we'll do is when we run each one, we'll then process them and have to go back and we will manually update the calibration.
So are there manual updates available?
We can do automatic as well.
I mean, like, can we do like we get a curve and we use that curve to still put a number in? Is that possible?
Oh yeah, once the processing method is calibrated, you'll have the curve, that calibration equation tied to each component, and then when you run a sample, it will yield a result using that.
Yeah, so I mean, like if we get a chromatograph first and then assign each value to the specific level, is that possible?
I'm not sure if so you get we could run these all right now, and you have that raw data, and then we can use that raw data to build out your curve, if that's what you need.
Yes, automatically or manually?
We can do it both ways. So manually is just reprocessing the chromatogram and then going into here, into the file and saying, use this chromatogram, or this result file in that case, use this result file for this level of your curve.
Yes, right, that's what I mean.
Yeah.
manually every area.
No, you don't manually. You tell it to use. You say select this result file, and then you assign that result file level 1, and the next one level 2, the next one level 3, and then it goes.
Okay.
There's another way to do it straight from the sequence, where you in sample type you say this is a calibration sample, this is the level of the calibration, and it updates the method automatically, so you don't have to bring in the result file. Because we're doing manual injections, I'll show you how to do it the more manual way. It's also better because then you actually look at the chromatography before blindly updating a calibration curve.
You didn't update the concentration.
The amount.
Thank you. FA, curve, first order, level 1, level 2. And there are ways, so if you assign a different level, like for those hydrogen ones, we could say have a specific level for just hydrogen. So because you have 5 calibration tanks over there for hydrogen, you can have hydrogen 1, hydrogen 2, 3, 4, 5, and then use those 5 runs to build out a calibration curve
For hydrogen specifically.
for hydrogen specifically. Okay, 0.1, 1.
So we cannot integrate that hydrogen data in this calibration.
You can, yeah.
Okay.
But we'd have to run them independently, right?
Okay, yeah, I know.
Yeah.
But after running, we can also, I mean, like if this hydrogen curve is not straight, we want to, that hydrogen data we can incorporate here.
Yep.
Okay, that's good.
So what we would do is we would build out its own like level.
Okay.
So
So, for example, the hydrogen gas only will be level 406, or
You
can
can
it still be 1 and 2 and 3?
You have delete these two if you know they are active.
you can delete them. Yes, you can. What I would suggest in that case, because we're going to 5 levels for hydrogen, and you don't want to disrupt the
This-
calibrations for your other samples. I would label them as like H2 level, like H2 level 1, H2 or yeah, H2 level 1, H2 level 2, and so on, so that when you go to calibrate those levels, you don't throw off the rest of them. Let's say there's like a small amount of oxygen or something, because there's going to be nitrogen in those. You don't want to throw off your calibration for nitrogen if you're calibrating for that. Level 2, level 3.
Did you apply the oxygen? Can you check? Oh, great, you did.
Nitrogen's balanced, so we don't actually have to calibrate it.
We don't have oxygen actually.
It does, is it?
It might not be in there.
Oh,
It's okay.
But we have the actually air. We can use the 25% to calibrate the oxygen.
I'm just because nitrogen is the balanced gas, so we won't
Is
update
that,
that. And if you want to just use a single point calibration, we would use average calibration factor. So let's go for oxygen. Let's say you wanted to use 21% for air. You would just use an average calibration factor, get rid of these levels. And then we could just have and then your amount is 21%. And so this is just going to be a single point calibration. So it's going to, excuse me, just draw a line through the origin and through that 21%. and generate a response factor.
Yes, but that would be very inaccurate. It's not. One thing is single points, and also it doesn't have to be across the origin.
No, exactly. It is less accurate. It all depends on the use case, the application, what standards that you can have available. There's some applications where the standards are so expensive that it is cost prohibitive to have multiple levels.
Yeah, but the hydrogen, the 500 bottles,
They have oxygen in
they
it.
have no not oxygen, but they have different levels of air, and if it times 21, then it's all different percentage, right?
If they have different levels of oxygen, then you would just have to calculate them out and put them into the amount field.
That's enough.
Yeah. So since we're not calibrating oxygen right now, I'll just leave it out. So okay. Okay.
But the nitrogen, I think we can calibrate it.
In here, it's just balance. So
Yeah.
you could, but
We have like, for example, 93
And yeah,
and the 60 something, 65.
you could calibrate if you wanted to. Are you measuring nitrogen in your reactor?
not actually.
I don't know, but this age will give you pretty weird results.
Okay.
Table. Oh,
It just won't have a-
it
it'll
will
have
not.
a-
It
One of the
will-
concentration.
Yes, it will not rate the peak.
It will give you a peak area, but it won't give you concentration.
Or we can do it later. Doesn't matter.
We could, okay, calibration. So it's also if your nitrogen that you're going to be measuring, considering the lowest level will be like 95%. If the nitrogen you're measuring is 2%,
Yeah, then that would be
inaccurate as
yeah,
well.
yeah.
So use curve, first order. Whoops. Ah, one, down, 5. Okay,
So the massing can be
thank you. And then we'll just double check.
yeah, it's okay. Like and all set up, just run, which is that's how it works. Yeah.
And so from that now we will build out a sequence with the three samples. And we'll create a sequence from new. Okay. First thing we do is select that, GC. We will do multiple injections per row and vial by vial. Okay. This is going to be training calibration. Our instrument method is going to be 12-minute single method. Okay. Our files, our processing method. We're going to use Arnell processing 12-minute single. That's going to be our calibration method. We don't have a report format yet, but we can build one. So data, the first sample is going to be, what we'll just call it cal 1.
We know on 1%, and then we have this one. We can save this one for the future.
Yeah, we can do that. So this would 0, 1. Okay, and then this will be 1, 0. And then it should be 5. Okie doke. Oh, darn it. Okay. So our output's going to come from this channel here. We'll get an introduction into tokenized tokenized naming conventions. So if I right click into the data, I have this drop down called edit token string. And this is where we can add in a tokenized convention. So here we can add in the day of the month at the starting of the run, the day of the month at the starting of the run, and then the year at the start of the run. And I'll get rid of these values here. So you have this information, and then it gives it like a timestamp.
Oh, that's good.
Except for what I wanted to do is this will just take a second to set up here. Do the same thing. Day, month, year, separated underscore. Okay. It always has these number signs on it, which we don't need. Here. Sorry, I'm just trying to make these a little neater.
So why after we add the token, there always be several.
Number signs?
Yeah.
Yeah. It has to do with the. I think it's a global parameter. There's a parameter in when we were setting up the method. It has like one of the boxes where it's like it adds numbers. The point is it does that so you have unique file names. Here too, it's doing that 000001. Okay, yeah, I was worried about this. So what it's added another token on here, which is the channel. And so we'll say detector A or detector B. This should be a single channel method, so I'm curious to see why it's giving us 2 panels, but let's run it, see what happens. So we'll go from here, we'll go, if you wanted to do it automatically calibrate the method from here, we would select cal replace as the sample type, and then it's gonna generate a result file and automatically use that result file to update the
Processing.
process. Yeah. I'll go through the steps on how to process the sample and then bring that result file into the method to show you that process as well. And if we were to do replicates, we would use replicates of a single calibration level. We would use cal average. Cal replace, if we have an initial, we have a calibration and we're looking to update it, it's out of date, whatever, it's old, you use cal replace for the first sample, for that particular level, you use cal replace, and then if you have an additional 3 replicates, you would do cal average for the remaining replicates. The idea is cal replace overwrites that old calibration data, and then cal average takes the new values and averages them to that value. If you just continually use cal average, it will average the new points with the old historical data. So that's why we would use cal replace to overwrite the historical data, and then use cal average for those other level replicates.
But the cal replacement, is it level specific or it will replace the
Level
whole?
specific.
So where to set out the specific level?
Because we're not, so if we were to select it as a cal replace, if you look over here, there's now a box that has the levels. Yes.
Okay. Yeah.
And then you can also select to update retention time, no, yes, replace.
Oh, okay. Yeah. Okay. Yeah. That's good.
So now it's just a normal sample. I don't have access to those drop downs.
Oh, okay. And average is also level specific.
Yeah, yes, yes, it is.
So like I just have some data or saved in computer, just using the data as calibration sample. So that's what I can after. So I can import the data directly to the method to modify
The calibration, yes,
calibration.
which is how we're going to do it right now. Okay. So we'll start row 1 and we'll end row 3. I'm not going to turn off processing and see how it goes. Okay. While that's setting up, let's see what's going on here. Do we have to roll these around? Do you have like rolling rags? So the gas samples can
Stay as a
set, some of the samples are
heavier.
right?
Yeah.
Really?
The
Yeah.
heavier gas will be as
Oh, I thought they will be mixed up.
different the density, right?
Yeah, still, but they're very tiny.
In one of the demo labs in the U.S., if you see,
Maybe we do it right now for you.
Just do this way.
roll it across the floor. Yeah. Generally, there's you can get them. They're like bottle rollers. So this is pretty simple, but for some of the RGA mixes can be quite busy as far as a lot of components. We have repurposed a hot dog roller, like you see at like the 7-Eleven. They're just like rolling.
Okay.
Yeah, we've got one of those. You put your gas bottles on it, and you just roll.
We have a roller other lab.
Yeah, right.
We can put it there.
It's a hot dog roller. You definitely don't want to hit it up.
No.
Okay, so for the first bottle, we can try the menu, and the second one we try the replace. Can replace.
The sequence is already loaded.
Oh, okay. Yeah, it's okay. Yeah, I just want to see how it works.
The mix test 1, 2, 3. So
Yeah, because level 1 we're gonna manually input the area into it, but level 2 or level 3 maybe we can try replace.
Is there anything I need to know about this?
It's very simple. Just open it now, isn't it?
Is it gonna just blow my syringe apart?
No, I don't.
So this is. Do we have a new syringe that anyone wants to use? Because this has had a bunch of.
Yeah, we have a lot of things.
So this is 30?
This is a 30, yeah.
30, yeah.
I just because it's had a lot of the RGA blend in it, I can smell it whenever I expel.
This is also dirty.
That'll work.
Just spit the air out.
Is it gonna?
Oh, put the hand here, otherwise it will. Yeah, here you go. Yeah, I gave you one already one.
Okay.
So this actually this line has an fringe.
You need to tight it up pretty tight, or it will get. I mean the no I mean here, yeah, or it will continue leak.
So in my defense, I have not used this contraption before. But who wants to hit run?
Right to go. Okay, run.
No. No, we'll do this and then I'll disconnect. You can hit run there, yeah. And then you want to hit start.
No.
With this specific method, using the TCD,